In this video, we're going to talk about some of the rules of exponents, and this is more for those of you who are a little more advanced, so we're just going to kind of breeze through some of the basics and just talk about some of the more complex a little more in depth. So the first few that are a little easier to remember, the zero exponent rule tells us that any base to the power of 0 is equal to 1. So the base becomes 1, and that 0 exponent is gone once we've changed the base. The product rule is saying when we multiply the same base, whether they are a number or a variable, we have to add those exponents. So, for example, if we had x to the power of 2, that's like x times x, and we were multiplying that by x to the power of 3, well, that's x times x times x. So we have 2 x's here times 3 more x's, that's a total of 5. So we add those exponents. Here we only have one base, and we have a power to another power, or a power of a power. In this case, it's kind of like what we see when we distribute a number in front of parentheses, but we just multiply the exponents here. So if our base is a number, we don't want to multiply that base times the exponent here. We always want to keep the bases together and the exponents together. We don't want to cross those up. So we're just distributing here. Think of distributing like with bases in front of parentheses, but now it's just with the exponents. Power of a product, well, it's the same principle we use up here, but we're distributing that exponent on the outside of the parentheses to the exponent of each base. And this throws us off a little bit because we don't see the exponent for a and b here. So the exponent is a to the first power and a to the first power. So we do n times 1, n times 1. We get a to the nth power times b to the nth power. So quotient rule, kind of similar to with product rule. Now if we're dividing the same base, we subtract that exponent. So if we think back to the x squared and x to the third, let's say that this is x to the third and x to the second. Well, if we have x times x times x on the top, x times x on the bottom, we can cancel out 2 x's on the top and bottom, and we get 1 left up top. And that's how we get that's what we can do with the subtraction there. We would take 3 minus 2 and get 1. So power of a quotient, if we think back to the power of a product or power to a power, we've got this exponent on the outside. We have to distribute it to each base. So it becomes a to the nth power over b to the nth power. And then the negative exponent, if we have an exponent with a negative sign, it's not simplified. So kind of like with a 0 exponent, we don't want a negative exponent in our final answer if we're trying to completely simplify. So that negative exponent takes the base and flips it. So if it's in the numerator or if there's no fraction, it gets put down below into the denominator. If it's already in the denominator and it's negative, so if this was 1 over a to the negative nth power, then it takes that base in the denominator, flips it up to the numerator, and it becomes a to the power of positive n up top. If we have another example here, well, it's just the b base that has a negative exponent, so the a to the m power stays put. It's just the b that gets flipped and put underneath. The negatives get really tricky when we've got a lot of different terms in there, or variables and coefficients. So another example here, we see the 3 is totally fine. There's no negative exponent. There's no 0. We're not simplifying that at all. Same with the m. The b has a negative exponent, so we have to put that in the bottom. The 2 is fine. The x has a negative exponent, so that gets flipped up to the top, and the y is fine. So we see basically the b and the x just flip around because they both had a negative exponent, and now they're both positive once we flip it. The fractional exponent, that can be a little tricky too. So basically, if you have a to the power of m over n, so if we think of, for example, 3 over 2, that denominator, you can kind of see it here, denominator of the exponent becomes the root. So if this is 3 over 2, it becomes second root or square root of a to the power of 3. A little larger breakdown of that, if we have a to the power of m over n, again, think 3 over 2. Well, 3 over 2 is the same as 1/2 times 3. So we kind of split up that fraction there. And then 1 over 2, or 1 over n, that's the root, right? So, well, if these are being multiplied, we can kind of go in the reverse order with power of a power. And now if we just look at what's inside parentheses here, that's that, oh, that is an extra a that's snuck in there. We'll just kind of cross that out. And that's not there. So the a to the power of 1 over n becomes the nth root of a, and then we still have this power of m, and it actually doesn't matter whether that m is an exponent outside the square root or inside. You could do either way, and it would give you the same value.